Good evening, Manandar. And today we are going to discuss sixth unit, block 3, sixth unit. It is a derived data types. Derived data types, it is main concepts are the arrays and structure and unions and files. Arrays concepts, it is a whenever we need that is here, arrays are the three types. It is a one-dimensional array, two-dimensional array, multi-dimensional array. It is array is a mostly it is a effective storage of the data in a particularly with the reference. That reference is a based on that directly we can go for that is a simplification or calculation with the reference of this particular value that is easier on this arrays. So the most useful in arrays. One-dimensional array, two-dimensional array, multi-dimensional array, three types of arrays. Here, first we go for that is a one-dimensional array discussion. In this one-dimensional array, it will go for that x of 0. X of 0, it is a location is a 0. Their corresponding value is a 20. X of 1, location 1, value is a 30. Example, here in the screen here we are showing here. X of 3, x of 3, the corresponding value is a 5. So location is a 3. And corresponding that, we will go for that 4 and it's a corresponding 0. 5 location. How many are there? 7 location. It's corresponding 0. Here array representation takes that it is a x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 7. What is that meaning of that? It is a particular location place in that variable is declared as a value is a corresponding values for the locations. This is called as a main important utilization in the arrays. Now here multi-dimensional array, it means that it is a two-dimensional means here we can take that x of here first bracket and second bracket. First bracket it goes to the rows and the second bracket is goes to the columns. So corresponding that in the beside another bracket will come. This is comes to the here columns aspect. So that it is called as a rows and columns. So this is called as a two-dimensional array. Here the example is a 0 and 1 I am taking. Means it is a first 0 row and a first column. 0 rows and first column. That corresponding element is I will use the 10. So in here two-dimensional array, it is a matrix point of view. Here, rows and columns are needed. Such cases I will use that it is a two-dimensional array. Two-dimensional array means it is a location is clearly, particularly we know that reference 0 and 1. So that value we know. So that variable is a x. X is taking that is a 0 row and first column is a 10. At the time, your debugging aspects, it is not effect on this element. So that is the most observations in the two-dimensional array. If I take into the multi-dimensional array means it is a three-dimensional array. I will take it is a first corresponding row, corresponding column, and corresponding particular value. First is a reference, particular reference of it is a first matrix. If I take this is a first matrix. It's rows and columns we can take. And second matrix, rows and columns we can take. Third matrix, rows and columns we can take. It is a with the identification of number of matrices or number of allocations we can take in that three dimensions. Here, x-axis, y-axis, z-axis on that basis of that, like that we can be apply. Now, sir, can we do that is a fourth bracket also? Yes, it is. We can go for it is comes under the category of multi-dimensional. Here, usually we use that is up to two-dimensional or three-dimensional aspect only. Now here, sir, what is a one-dimensional? One-dimensional means it is a corresponding value, only x of 0. That's all, x of 0. It is comes to the one-dimensional. One-dimensional, it takes that is a directly value is a something 5 means it is a 0 element. Whenever I will use a 0 location and their corresponding value will take the 5. This is a one-dimensional. Two-dimensional means rows and columns will be there. And three dimensions means it is a multi-dimensional. It comes to the rows and columns and the corresponding expression. That is a expression means it is a comes to the allocation. Which allocation you are giving? First allocation, second allocation, third allocation. Now here defining that is array. It is arrays are the defined as just like ordinary variables. it means that is a variable, except each array must be the accomplished with the size of specifications. It is a number of elements. The expression is usually written as a possible integer constants in the general terms as a multi-dimensional arrays. Now, corresponding example, if I take, it is a int iteration 10. 10 iteration elements I am taking. Here, 10 into 15 means 150 elements I can take. It is a, here 10 will be take, there is a rows, and 15 will be take the columns. Here float, if I take float values, it will be take. And cube means it is a three-dimensional. It is a rows, low columns, and it is a depth values also. So it is this is kind of expressions will go for it is sometimes we can data type representation general form we can be take that it is a digits of 10 of it is equal to 0, 1, 2, 3, 4, 5 like that. It is also represent this is a 0 element, it is a 1 element, 2 element like that. It is a representation. The corresponding values if I take 0, 0.5, 0.0, these are the values. Here, characteristics of the colors, if I take red, E and D like that, we can take tabulated forms, multiple equations also represented in this initialization case also we can use this one. Now examples, it is a corresponding, it is a particularly element corresponding, considering the following the arrays definition. So we can use the digits of the pi. At the time, it is a 3, 3, 3, it will take. It is a int digits of 1, 2, 3, 4, 5, 6. And float, it is a 0. Colors will take the red and colors will take the red. And passing array to the function. An array name without square brackets and can be used as a argument to a function which is a pass entire array to the function. When an array name is a pass, actually it is a passing the address, first element to the function. Thus, it is not the same as a passing the ordinary variable. This is a particular function representations. If we use there, we have to be go for the passing of the array. Here, for example, if I take it is a average of the elements at the time functions also in that arrays I will be used. For loop I am using and corresponding that x plus sum I am getting. After return, that is the sum divided by number of elements. So I am getting now here we go for that is the points and the one-dimensional array. Pointers and one-dimensional array. Pointers will be represent, it is a percentile d x of I. It is a star xi, star of x plus I. Star of x plus I, it means that it is a address, arrays address like how we are represented. Similarly, here directly star will be represent. It is a dynamically that address. Dynamically that address. So here xi plus 1, it is addressant of xi plus 1. It is a xi means xi and xi plus 1. Both are represent the address of ith element. It means that xi and the xi plus 1 star is both are represent the same address. So here that address is our dynamical representation point of view. We use these pointers. Pointers is represented, for example, it is a hash include stdio.com and main is the same. Bracket is the same. Now inside what you are writing the program that will be executed here. In the dynamic memory you want to use in the dynamically, that dynamical memory we can be used in the pointers. Here, multi-dimensional arrays and pointers. Here, arrays in the pointers we can be used. That will be represented here. Expressions are, there is a data type and array name and expression 1 and expression 2. Now, here we go further. It is a representation of one-dimensional array. This is a representation of two-dimensional array. This is a representation of multi-dimensional array or 10th dimension. 10th dimension means x plus 9. So this is goes to the, it is a pointer representation is like this, and corresponding that it is a all the this is called as a representation of arrays. This is called as a representation of pointers. Now We go for that. It is a, for example, find the frequency based on the classes. What we can take here, here these all are the wide main, all will be, we know, generally we will take. And their lower limit and class length I am taking, and corresponding elements, initial declaration variables we are taking, and clear screen. And lower, it is a scanning scanner. It is a what is a lower limit I am taking? It is a class interval I am taking. Then again, it is a number of classes I am taking. Then it is a what is the maximum number of observation I am taking. Based on the maximum number of observations, I am creating that number of elements of array elements. Then we can go for that. It is a lower element, lower plus class interval minus 1. It is the upper element. It is a lower element plus class interval. Then it is represented into the J plus 1. Whenever we create the maximum, then based on the condition, we can be find out this float per point of view. Then it is a for loop. It is a for I equal to 0, I less than NC, I plus plus. Then it will be the frequency will be the represented in the table. Now calculate the frequency distribution based on the raw data. Here raw data if we give at the time, here also program is the same. Now here program initializations already we have taken. Then here what we have taken size and initialization, clear screen, print number of observation, elements. Elements means it is a for loop and its corresponding elements of arrays. Next, it is a comparisons I'm going. A of I greater than A of J. It is a observations and then given the observation. Then after that, again, we go for that the frequency calculation logic. Then automatically, while it is a 15 elements, I'm taking that. Whether it is a comparisons or the exist or not, then automatically count plus plus. So we can get that is a frequency based on the raw data. Now it is a program to calculate the result. Geometrical mean. Geometrical mean will be the, we can calculate for the given raw data. This is a library files. It is a wide main. Then clearly here initializations. These are up to clear screen. All of the initializations. Lower limit, class interval, and total number of classes. And here incremental additions. Then it is comes to the, it is a frequency class. Will be taking the SF plus equal to F of I. Then it is a for I equal to 0, I less than NC. So here S log E plus equal to 10 log of. This is only the frequency observation. Then after that, we can go for that is a mean, geometrical mean we can be calculated. Now here calculate the harmonic mean, same procedure. The logic is the same up to here. This is also same. Then logic last will be changed. This is comes to the logic sum of pi I by xi is called as our required harmonic mean. Next, calculating the weighted means. Weighted means it is the same process. Weights we have to be take the identification and a wi into array element x of I. So that I will get that is a new element, new values. That based on that we will be identify the same mean we can be calculated total by total number of elements. Next, it is comes to the one topic here over. Next topic is comes to the matrix operations with arrays. Matrix operations means I will create the matrix. That matrix means I require the two-dimensional array. I mean that I am in the two-dimensional array. Here, now first for loop will come to the here declaration of include preprocessors and wide main all are the same. Here wide main instead of that we can take wide read underscore main. Int of the matrix, int of the rows and int of the columns. So rows and columns and so that all will be here. Now here enter the values. Values I will give. It is a scanf I am putting. It is a matrix rows and columns I am giving here. Here printing the rows and columns. So here rows and columns automatically it is printing. This is a next I am going for there is a matrix creation I created here. Matrix creation completed. Now after that clearly I can go for that is a matrix multiplications. Here two input matrices, I will rows and columns I will create. Then it is a sum equal to sum plus matrix 1 of I comma k into matrix 2 of k comma j. So it is called as a matrix multiplication we can be used. Addition of the two matrices, I can go for that is the same way. Two matrices, first matrix I will create, second matrix I will create, just I will add it there for loops. Here matrix first two matrix creations, whether we can take it or not, just checking. Then it is a matrix additions row, its corresponding row and column corresponding column will be added. It is a matrix addition, multiplication, all single program we can be write here. This is only the matrices. Next is comes to the, this is what we discussed here. Matrix operations. Now it is a arrays over. It's examples over. Pointers also we can be used. Next, matrix operations, addition, multiplications completed. Now, storage classes. Storage classes define the scope of the visibility of, and the life of the variable during the runtime of the program. That is called as a auto, external, static, and a resistance. For kind of the storage classes we have in the C program. Here, auto means auto variables are available only when the block and when the block ends, and these variables are freed. Next, another is the extern. Extern also storage classes, allowing the variable into the defined into in some other block. And static. Static variable are the declared as a global variable with the local scope. And a register. Register variable are the similar to the auto variable, and but they will be declared into the CPU register if possible. Next year, storage classes, how will be represented? Auto, extern, static registers. It is a CPU registered cases we will be used, storage area. And it is a, when it is a static is the data segmentation place, area we can be store. And a data segmentation is extern, and stacks places it will be the auto can be storage classes. Initial values is the unspecified cases, and in this blocks will be there, and the end of the block it will be the answer we can get. Here extern if I use global multiple files will be there, end of the program we will be get the result. And extend static is comes to the data segmentation, initial value is 0. It will be represented blocks end of the program. Next, the register CPU registers and unspecified and blocks and the end of the blocks. These all are the address of the register variable cannot be obtained, and the hence the pointers cannot be used. This is one logic we should be remember. When the register key is declared, the registers in the CPU are limited, so that it is a frequently used these variables are declared in the CPU. Writing of the program. If I take that, it is clearly ash include stdio.h. Global variable I am declaring in the outside. Then void test, it is a testing I am doing. Here A5, B10, C10. Here print the values are the A, B, C, and extern into X is a value of X is it will be calculates. What is that? It is a plus plus, B plus plus, C plus plus. These all are the incrementals we have taken. Next, int main, it is x equal to 1. If I take, it is a test is a, I am calling function, call test function and term. It is a, then print of value of x, it is a percentage. X equal to 20, it is a test bracket, call test again. So print a value of x, it is a percentage. So return to this. This is comes to the here both the initialized case how we will be we can be use this. It is a storage classes. This is summary. Next, structures and unions. Here, structures and unions. Here we will be use that. It is a structures and unions. Yeah, struct, start. If we take, that is a tag will be take the members. Tag will be take the members. For example, whenever we will go for that bookstall. Here in the bookstall, how many books we have? Number of books. Here, number of authors, number of available in the market. Next, it is how many are sale, how much cost, how much profit. These all will be coming to the one place. At the time, we will be use this kind of the structure. This kind of the structure. The here also we can be erase. Our use arrays are the pointers. So example I am taking here. See here character name. One book name I am taking. It's one person name I am taking, age and salary. These all will be the one person information. That all in a single point of contact. So that it is called as a structure. Next to using the structure, it is a consider the following the structure declaration, structure data in the day, month, and year. Then after that structure account, it is a name, account number, account type, and float and balance. This is come to the on customer information. So this is an example of the customer information. This is we can be used that structure. Next to user defined type. Here user defined type means how we will be represented. Existing data and new data type. Now that is also one structure form. It is comes to the here all the member type, new type of the members. How many are the structures of member having? 1, 2, 3, so on m. M members information. Example, if I go for name, account number, account type, and float balance, it is a record will be the available. So it is a different kind of information will be stored into the one place that is comes to the structure. Next to pointer to structure. Pointer to structure mean that it is a data is a more is needed at the time. It is a I need the address also. Arrays, instead of using the arrays, I will use the pointer so that it is a more data I can be collected here in the structure. That is called as it is a pointer structure. Pointer structure. Example here, this is comes to the structure and I want to be used that is the sum of operations on the structure. Next to passing structure to the function. Here, this is the structure I am taking. Then after that, pointers also I will be taking. It is I will use that for loop and all the representations of it. Calculations. In that I will use that. It is a passing instead of one variable place. It will be replaced to the another. So that value will be the we can use for the calculation point of view. That is called as a passing structure of functions. Next is self-referential structure. Self-referential structure, your structure tag I will use. It is comes to the same I will use in the pointer name I will use inside. That is called as a self-represented structures. Next, it comes to the another example. That will be, we can be used into the binary tree operations case. Because of it is a left or the right operations, it is happen. That I can check by using this. It is a temp left to equal to left temp. It is a right to, it is a right records we can be take here. This is comes to the total structure formation. Here we have a binary case. It is a right order and a left order. So succeeder and replacer. Then it is comes to some core nodes are the deleted in the tree. That will be the based on the condition I can be deleted. If and else conditions I will use. So this is comes to the under category of self-referential structure. Self-referential structure case we will be use this. Next, what of the example? Half-man code algorithm. Half-man code algorithm also we can develop by using reference self-referential structures. So here up to here, all the declarations we have, and I'm creating the one structure. Then I'm using into the various kind of the pointers array. Next, creating the nodes and verifying that which is the order is need. In that, I will identify the minimum heap. The minimum heap calculation point of view, we use the Hoffman coding algorithm. That logic is comes to the here, we will be use, this is the logic. So heap, minimum heap I can calculate. That heap calculated is called as the Hoffman coding algorithm. We call it. Next, swapping also we can be used with the pointers. Then it is a logical heap conditions. Then left and right will be accepted and swapping will be happen. Then finally, in terms of minimum, we can be identified extreme minimum. Next, minimum heap will be the condition we can be check it logically. This is a total program for how to write the up to here. This program is called as a Hoffman coding algorithm. It's most important. Next, program implemented the birth first search. This is also important. Birth first search, it means that it is a one-to-one element will be the checked for that. Such a way we have to be identify that structured queue. Structured queue we can be identified. That is called as a birth first search. Your structured queue is will be the integers items in the format. Here queue structure I am taking here number of items and font and array. Then after that it is a queue structure and a queue structure DQ or display imply empty and print queue all we can be do. Structure nodes. This is algorithm is called as a BFS algorithm. But first search. The graphical graph it will be give. In that it is a start queue. Then it is a total simplification part. So that I'm getting. Next creating the nodes. Node. Next creating the graph. Adding the edges. Creating the queue. And calculating the empty queues and adding the elements in the queue. One is a one program. Removing the elements in the queue, fitting the queue, then structured graph. In that graph, which is a shortest route, we can be identified. This is a overall idea about that is the structures. Next, to go further is the unions. What is a unions? It is a collection of all the objects. This comes to the union. Union means all we can arrays representations we can take. For example, character, structure data, float, and previously all will be the in the one format. Here it is a different kind of the format we can use. Different kind of information so it can be gathered. So here name I can take and data names, pointers, float numbers, and number of integers, all will be the mixed up with this comes to the union. This is a total overall view. Last one is the files. File basis means it is a here clearly here we will be use the operations. R means it is a open existing file and it means that reading the only. Directly it will be file will be open and we can be read. W. That file can be open and we can write in that. ARW, read and write. R plus is called as a both read and write. W plus is a read only and a write also. Next it is A plus, both reading and appending. Only appending. Next to WB, only numbering, binary writing, read and write. These all comes to the files. That files will be the pointers files. So if I use this logic and automatically output we can be display. Outputs we can be display. That is the main advantage of this files. That the program total will be the calculation part. After that, results will be the printed into the Word or some other text file. So that results we can take into the some text files. That is comes to the file. Advantages of the file. End of the file, EOF we will use, then that will be the displayed. What is we got it, the output that we can be displayed. For example, it is a file start. Here this is a program style. Then it is a file F and character name, FP open and FP equal to null. Then it is a creating of the test files. Then example, F is closer. So this is a exit. Then it will be represented into the output of the program. Next, it is an example one. Also the same progress of the file. These all are the examples writing in the program by using the functions. Operations on the functions also we can do. Commands, lines also, arguments also we can do. At the time, what is the star AP input you will give and output what you will get it. So that comparisons also we can do it together. That is called as operation files and a command line arguments also. So here, if FOP output equal to null, then while CH is equal to not equal to pin, not F pin is not equal to EOF, then automatically off print will be the over, starting and output will be over. It will be displayed into the text. The text where it will be the display. That is one of the example. Finding the current locations also we can be use this logic. Random access also we can use this logic. Next is one example for that. It is a read plus write mode. I want to be using. So here, this is a program style for the read and write. Another example for that, it is a Q star sort. It is comes to the here. This is one other example. Next, command line argument. Command line argument also we can identify that it is a argument which is passed to the main and modified accordingly. That will be the command line arguments we can check. This is some. Next, it is comes to the block 4. Block 4, it is a classes and inheritances and polymorphism. Here, object-oriented programming paradigms, it will be, we can be see that classes and objects, inheritances, and overloading arithmetic operations also you can check. That all point of view. Then it is a crystal clear code approaches we can check into the polymorphism. Here, these all are the observations for the classes and objects. In the OOPs, there we use these are the commands. This is a smallest examples. C++ classes, objects, and input-output structure, statements, and access specifications. How we can be taken the program that we can see. some specifier and access. If the public, if I use what purpose, private if we use what purpose, protected protected we use what purpose. The derived classes we can use. One example. This is a only overall idea about it. Local variable declaration, if I take how it will be represented. Data members and member functions and constructor and destructor. These all will be the one of the logic. That is the concepts and corresponding programs. We are using the arrays of objects, pointers to the objects. Dynamic creation of objects, automatic typecasting will be there. This is the overall idea. Next, the functions overlaid and the garbage collections also. Will continuation will be discussed. These are the overall for observations today. Yeah. Thank you, Ananda.